Let us assume that we have this complex function, complex valued function, f of z, which is equal to u of x comma y plus I times v of x comma y, where f is an analytic function, so that the functions u and v are harmonic. We take into consideration that f is an analytic function, and since f is an analytic function, the Cauchy Riemann equations come into play. So the Cauchy Riemann equations. These equations are the following. Partial derivative of u with respect to x is the partial derivative of v equal to the partial derivative of v with respect to y, and then partial derivative of u with respect to y is equal to minus the partial derivative of v with respect to x. We want to show that u and v are harmonic functions, so what do we have to do? Let's go to the first relation and take the derivative, the partial derivative with respect to x. So we will have the partial derivative of this derivative, which is the second derivative of u with respect to x. And this is the mixed derivative of this form, equal to the mixed derivative of this form. Now we go to the second relation and we take the derivative with respect to y. This is the second derivative of u with respect to y, and we take the mixed derivative is equal to the mixed derivative of this form. We add these equations together and we obtain the following result. Now this mixed derivative minus the other mixed derivative, this is obviously equal to 0. Consequently, we have that this equation is equal to 0, and this is the Laplace equation, which is Laplacian of u is equal to 0. Therefore, u is a harmonic function. Now let's go to take care of the function v and show that function v is also a harmonic function. We go from here, we take the derivative with respect to x, and this is the second derivative of v with respect to x, which is minus this mixed derivative over here. And then we go to the first relation, we take the partial derivative with respect to y. So we add these equations together and we obtain that the second derivative of v with respect to x plus the second derivative of v with respect to y is equal to minus this mixed derivative plus the other mixed derivative. We have the same mixed derivatives and we have opposite signs, so this is equal to 0. Consequently, partial derivative of v with respect to x plus the partial derivative of v with respect to y is equal to 0. Therefore, Laplacian of v is equal to 0. So, v is a harmonic function. Therefore, the functions u and v are both harmonic functions, which is a really significant result in the complex analysis. This operator is a second order elliptic differential operator. It is second derivative with respect to x plus second derivative with respect to y. It's a linear operator. It hits, so when you take the Laplacian of a function w, this should be the Laplace operator going directly to w, so this is linear. Partial derivative of w, the second derivative with respect to x plus the second derivative with respect to y. I hope that you enjoyed the video, and I really wish you the best for the rest of the day.